Hello, welcome to the water solutes lesson. Right, this is lesson 3, C3.5, the EdXL triple extension science specification. Right, and I just thought I'd speed up things a bit here just by jotting out our objectives, stroke outcomes, as almost some. So, we're going to talk about what hard water is, right? I'm going to define concentration. You need to explain what hard water is. You need to describe the problems caused by hard water. I need to explain how hard water leads to the formation of scum. Right, this is like a good student of mine. His name's Yusuf, and he's going to lead.
Hello. Hello. I'm recording.
I'm recording. Yes. Okay. Right. Yeah. I suppose that got a few laughs. Have a good night, Yusuf. So first up, we're going to define concentration, and then explain hard water, what it's called. Describe the problems caused by hard water. My view. You need to explain how hard water leads to the formation of scum. Soap used. We live in London, actually, like hard water, and we get that from quite a lot. And then some of you, we compare and contrast and detergents. So, what is concentration? Well, I will find concentration as the amount of substance dissolved in a given volume of solute. Of solvent. The amount of substance solute dissolved in a given volume of solvent. Right? So the key terms here are amount and volume. So it's amount of solute divided by volume. So the equation for concentration is concentration equals amount of solute. Okay, amount of solute divided by volume of solvent. Now I hope you know from your 7 and 8 work that solute is the thing that dissolves in a solvent. Right? Sorry about that, I'm a busy man, just had a quick phone call. Anyway, let's continue. So, amount of solute. Now, the amount can be expressed in lots of different ways, okay? Good units for amount, right? The best unit is really the mole, right? So, I know some of my students now have done quite a lot of work on the mole. We will talk more about the mole online pretty soon. You could have a gram, you could have a kilogram, okay? Those are, you could have milligrams. All of these are possible units for amount, but mole is probably the best. Volume, a variety of units for that as well. The standard unit for volume in chemistry is the decimeter cubed, which is basically a liter. Right? Decimeter cubed and a liter are the same thing, but there are other volumes you can use. You can use a milliliter. You can use a centiliter, right? You could use a centimeter cubed, which is the same. Let me just highlight that. So I'm sure you know that a milliliter and a centimeter cubed are the same. Just undo that. So a milliliter and a centimeter cubed are the same thing, and a decimeter cubed and a liter are the same thing. So what units can you have for concentration? Well, the standard one is the mole per decimeter cubed. That is the standard, and we call this molarity. Right? It's a very, very useful one. Mole per decimeter cubed. So if your amount's in moles and your volume is in decimeters cubed or liters, you have mole per decimeter cubed, which is the molarity of that solution you have. But you can have others. Of course, you can have milligrams per milliliter. You can have grams per liter. Right? You can have a whole load of them. Right? So they will all be useful units for concentration. Now, we abbreviate this equation like this. C equals N over V, where N is the amount of substance and V is volume and C is concentration. Okay? So useful relationship here. Okay, that you're going to be expected to remember for your exam. So C equals N over V, or N equals CV. If you need that in a triangle, which I'm sure many of you won't, okay, you'll find that it's N at the top, CV, like so. Okay, so you might want to write that down somewhere. So it's NCV. So concentration equals substance over volume. Excellent. So that's what concentration is. Next up, explain what hard water is. Alright, hard water. London is a region that contains a lot of hard water, and hard water is water that contains magnesium, more principally contains calcium, Ca2 plus, and or magnesium ions. Oops, just okay. Symbol for magnesium is Mg2 plus. Ions. Right, these ions can come into the water, or they normally come into the water as water seeps through rocks like limestone that contain calcium minerals in them, or magnesium minerals. So the water in London is hard because the River Thames, which is our main source of water, flows through the Chilterns. And the Chilterns are, I suppose you can call them a mountain range that have a lot of limestone in them. The water flows over the limestone, and the water flows over and through the limestone and leaches out calcium, so calcium ions, so the water's hard. So why is it a problem? Well, the problem comes when one tries to use soap in hard water. Soap forms an insoluble precipitate with calcium or magnesium ions, right? This precipitate is called scum, right? One of my favorite words in science. And it basically renders soap ineffective, which is probably why so many of my students seem so unclean, because they may be trying to wash themselves, but the hard water in London renders their washing ineffective. Fair enough. Okay, so that's essentially what you need. So lots of soap is wasted, and another thing is that this scum makes purifying and treating water more difficult. Okay? Right, makes it more difficult. Now you should know that in London, you see, the water is recycled. Much of the water that you drink has been through many people many times. It's because we're a very big city, and we need to preserve water by reusing it. So we get lots of water from the Thames, but a lot of the water that goes back into the sewage is purified, treated, cleaned, disinfected, and put back into our taps. If there's a lot of scum in it, the scum makes this purification much more difficult. Now, what has this got to do with concentration? Well, if we were to look at a typical bottle of water, you might find that it will give you an analysis of what ions are dissolved in it. So, Buxton mineral water, let me change the colour. You'll find that Buxton mineral water right? And Buxton mineral water is quite hard. It actually contains 55 milligrams per litre of calcium ions. So why don't we try and apply this equation to figure out how much calcium there would be in, let's say, 250 milliliters of water. So let's ask that. Let's change the color again. So how many, or how much calcium, or what is the mass of calcium, or what's the amount of calcium in 250 milliliters of mineral water? Right. So what we're asking for is N, right? So remember our equation is C equals N over V. So how much calcium in 250 mils of water? How much? So it's asking for N, right? Now it's given me 250 milliliters as the volume. Okay, so that's V. And the concentration is 55 milligrams per litre. Now my volume is in milliliters. Okay, so 250 milliliters is actually 0.25 litres. How do I know this? Well, you should know that there are, just as a little note, there are 1,000 milliliters in 1 litre. So 250 milliliters is a quarter of a litre, so it's 0.25 litres. So let's work out, let's put this into equation. So if we rearrange this to make N the subject, we'll see that it's N equals CV. So we write N equals CV. Okay, the concentration is 55 milligrams per litre. We multiply that by the volume, which is 0.25 litres. Now I needed to change my volume into litres because my concentration was in per litre. Now I must have homogeneity of units. That means the units I use have to be the same for all of my values, otherwise it doesn't work. Okay, so 55 times 0.25 is 13.75 milligrams. 13.75 milligrams. Why milligrams? Well, my concentration was in milligrams per litre. So the litres cancel out, I'm left with milligrams. So in 250 millilitres of water, there's 13.75 milligrams of calcium. Fair enough. Now I'm going to give you another one. So what if I told you that Buxton mineral water had a concentration of, okay, so the concentration of magnesium ions is, okay, so this isn't Buxton mineral water, is 19 milligrams per litre. Could you work out the amount? So calculate, so question, the amount of magnesium in 300 milliliters. Okay, pause the video and try and calculate it. So hopefully you've had a go at that. So straightforward. So we've got C equals 19 milligram per litre. V, my volume, is 3. Whoops, that's a pretty funny looking 3. It's 300 milliliters. We can't leave it in milliliters, right? Got to turn it to liters, so that works out to be 0.3 liters. Remember, just divide by 1,000 to turn into liters. Right? Move the decimal point 3 times. 1, 2, 3. And N equals concentration times volume. So my concentration is 19 times 0.3, and that equals 5.7 milligrams. Okay, stands to reason because the concentration of magnesium is smaller than calcium, so we're going to expect less, even in a slightly larger volume. Brilliant. What about using the equation another way? What if I gave you a volume and an amount? Could you calculate the concentration? So let's say you have, calculate the concentration. Concentration of, let's do calcium again. Ions. If let's say 100 milligrams are dissolved in 2.3 liters of water. Fair enough. So, brilliant. This is nice and easy. So, 100 milligrams, that is the amount. Let's switch color. So, N, which is the amount, is 100 milligrams. 2.3 liters is the volume. 2.3 liters. So the concentration is amount divided by volume. So that works out to be 100 milligrams divided by 2.3 liters. So 100 divided by 2.3 is 43.48. What would the units be? Milligrams per liter. So that's milligrams divided by liters. So it's milligrams per liter. Yes, excellent. Right. Okay, that's the basics. So if we go back to our objectives. Whoops, let's have a look. So we have, what have we done? What colour am I using now? I'm still in blue. Let's go to red. So, define concentration. We've done that. We've even used it. Explain what hard water is. Yes, that's water with magnesium and calcium in. Describe the problems caused by hard water. Yes. Can render soap ineffective. Produces scum when soap reacts with calcium or magnesium ion. Explain how hard water leads to the formation of scum when soap is used. Well, we have the formation of a precipitate. Now this is a little bit more difficult to explain, and I'm going to ask you to do a bit of research on that. Now, compare and contrast soaps and detergents. Right now, let's scroll down to that, and maybe we can touch that most objective. I don't think we really need it for the specification, but you do need to know what a detergent is and what a soap is. So, well, detergents and soaps are essentially the same thing. It's just that detergents do not form scum in hard water. That's the first thing. Also, both detergents and soaps form lather. Now, lather is literally just bubbles, okay? It's just that soaps don't form a lather in hard water because they form scum. So a lather are just bubbles, right? You know, bubbles. Bloop, bloop. So I know you all like to have a bubble bath. I know I like having bubble baths as often as possible. It's a waste of water. So bubbles in a bubble bath are a lather, a nice smooth lather, which helps like the soap get about and it makes them more effective. Detergents form a nice lather. As I'm sure when you wash dishes, you know, when you're washing your dishes, you use a detergent. Okay? Detergents tend to be harsher. Okay, so soaps don't tend to be as harsh on the skin, which is why we use them to wash our hands and our faces, or at least I'd like you guys to. Whereas detergents are harsher on the skin, okay? Okay, are harsher on the skin, which is why your mum tells you do not wash your hands with the washing up liquid, because washing up liquids are detergents. It's just not good for you. Okay, now